Alright, here I'm going to show you how you could use prime factorization to solve seemingly difficult equations. So here we have a question. The positive integers r, s and t have the property that r times s times t equals 1230. What is the smallest possible value of r plus s plus t? So you've got to find those three integers and you've got to find them at the smallest possible values, because there'll obviously be many different possible combinations. Alright, without knowing prime factorization, this could be quite a difficult question. So I'll just give you an example of how you would prime factorize a number. We'll start with a simple one, 64. Alright, so you start with finding the lowest possible prime factor, right? So 2 is the lowest possible prime factor, so 64 is 2 times 32, right? So 2 is our first prime factor. I'll just underline that. All right, now we factorize 32. 32 equals 2 times 16. All right, then we've got another prime factor there of 2. And it should be pretty obvious what you do from there. 16 is 2 times 8. Underline that 2 again. 8 is 2 times 4. Underline that 2. And 4 equals 2 times 2. And now we can't go any further. We just underline those last two 2's and we have all of our prime factors, which are 2, 2, 2, 2, 6 2's. All right, 2 to the power of 6 is 64. 2, 4, 8, 16, 32, 64. Right, that's how you can check that you factorized it correctly, that when you multiply those numbers you get the actual answer. All right, so now let's apply this technique to the question. 1230, all right, can obviously be divided by 2 because it's an even number. This is where your halving and doubling comes into play. It's 2 times 6, 15. All right, so let's underline that 2. It's our first prime factor. 615, it can be divided by 5, obviously, right, because it ends in a 5. So what would 600 divided by 5 be? It'd be 120, because 60 divided by 5 is 12. 15 divided by 5 is 3, so it's 123. Actually, I'll start with the prime number, prime factor. 5 times 123, and we underline the 5. All right, now we do 123. What can it be divided by? I know it's divisible by 3 pretty quickly, but a good rule you can use is you can add the digits up in the number. 1 plus 2 plus 3 equals 6. That means it can be divided by 3, so you don't waste time. Can't be divided by 2 because it's an odd number. It's 3 times 41, right? Because 120 divided by 3 would be 40. All right, so there's our other prime. And actually 41 is also a prime number, right? You cannot divide it by anything, so other than 1 in itself, which is the definition of a prime number. Right, so now we could check whether that works. 2 times 5 is 10. 10 times 41 is 410. 410 times 3, it is 1230. Okay, so now we can just use a bit of logic to try and figure out which 3 of the 4 numbers we will use. All right, so obviously we're going to have to multiply 2 of the numbers together to form one of our numbers. So we're going to have to include 41 because if we included it multiplied by any of the other numbers, it's not going to be as small as possible. So we'll try 41. Whoops, I just turned the underline off. 41. Right, now we need to include 2 more numbers. So the logic you want to do or apply here is to multiply the 2 smallest numbers together to create another factor. All right, so we'll include 5 as is, and then we'll multiply 2 times 3 to give us 6. So now we have 3 numbers, 3 factors. They're not the prime factors because we multiplied 2 times 3 because we're only looking for 3 digits here. 41 times 5 times 6. 5 times 6 is 30. 41 times 30, it'll be 1230. So these will be the 3 smallest, or the smallest total possible value you can come up with. All right, that multiplies to 1230. and adds up to the smallest possible value, which is 41 plus 5 plus 6. Actually, I'll change that to a plus 41 plus 5 plus 6 equals, and a bit OCD about formatting, 41, 5, 52. Right, and that's the answer, 52. Now you could try some other combinations. You've always got to include 41, right? So what if we had tried 41, and let's say we tried to keep the 2 plus 2, then we would have had to multiply the 5 and 3. It's obviously going to be bigger, isn't it? 15, 17, 58. It's in the choices, but it's not as small as 52. 52 is the smallest possibility you can come up with there. All right, so you can see most children, I think, would be daunted by this type of problem, and actually be a very difficult one if they had no idea of how to use prime factorization. So it's a very good skill to have, I think, to be able to apply the quantities, the attributes of prime numbers, firstly, to know what a prime number is, to know 41's a prime. I think I would quickly be able to identify all of the prime numbers under 100. For example, if you were to give me 97, I would know it's prime. I've worked with it enough. If you were to give me 93, I'd know, no, that's 31 times 3. All right, and you would know by adding the digits in 93, 9 plus 3 equals 12. So knowing about prime numbers firstly, and then knowing about prime factorization to solve problems like this.